So the first step in installing the IMS Solution or any IMS retrofit products is going to be to remove the gearbox and separate it from the engine. So we talked a little bit earlier about making sure that the bolts that hold these two together are in the right place. Now we're just going to assume that the last time this was separated, everybody put the bolts back where they should be, and that's probably a pretty good assumption because things have been okay for a lot of years. So Vu has created an indexing template for us here, and it actually kind of failed, Vu. But at any rate, it's currently failing, and we're just going to use this to protrude the bolts through in the locations where they're removed. So we started, position 1 is at 12 o'clock right here. This is actually the last bolt that we're going to remove, okay? It's the first. Damn it.
Hit that subscribe button and turn on notifications by clicking on the bell icon and never miss a video. We've got lots of Porsche content coming your way.
All right, so Vu has repaired our indexing template, and basically we got position number 1, which is 12 o'clock right here. That is the first position on the template. However, it's the last bolt that we're going to completely remove, because it is the one that will kind of hold the transmission together and keep it from trying to separate because of how things are set up on the table here. So as we start removing this, I just kind of go in a crisscross pattern, start with one of the ones on the side, go to the opposite side, and kind of break it loose, and pay attention as you do this to see if they're all kind of the same torque or not, because that would tell you that the person who put this together may have torqued it with an impact wrench and didn't torque it at all, or if they're all kind of the same and they break loose about the same, then maybe somebody did a really good comprehensive job and they actually used a torque wrench on this the way you're supposed to. Okay, so Vu has removed the majority of the bolts. We've only got one left in place. It's our number 1 bolt. And if you remember, I said we were going to take it out last because if you don't do it this way, the transmission wants to go ahead and falsely separate before you're ready for it to happen. So you can see it's already began to do this, but we just got this bolt in with our fingers and it's keeping things from separating. So here you can see our indexing template, and you can also see that we have 3 different lengths of bolt on this side, and we have a couple really long ones over here. So it's pretty common if somebody takes either of these two and they put them in this location. If this occurs, it breaks the crankcase of the engine, and a piece of metal will fall onto the bank 1 timing chain, which will conveyor belt it up to the exhaust cam sprocket, where it will then wreak havoc and can break that camshaft in half. So we've seen this happen multiple times. We've seen this happen from highly specialized Porsche shops that didn't know what they didn't know, or they were just in a hurry, they didn't pay attention, and they didn't look at directives, because there actually is a factory directive about this that even has the bolt lengths and where they belong. So when Vu was taking things apart, of course I said, hey, are you seeing that they're all about the same torque? And he says, yeah, except for this one. And the reason for this is because the last time this transmission was out, the engine was left in the car. This one's at the very top, closest to the bottom of the car, and you have a problem with access. So typically, if somebody is in a hurry or they don't have the access to this, they're going to end up trying to use long extensions with an impact wrench or something, and it's hard to get enough torque transfer on this one. So when you asked why it was looser than the rest,
yep,
that would be my hypothesis on that.
Yeah, so these here were all torqued relatively closely the same because I did it all by hand initially, and this one was really loose. This one here was one that I hesitated on because I couldn't tell from where it was located what kind of spline needed to go in there.
It's a triple square.
It's a triple square, and you can use a larger Torx bit, which would kind of work, but I didn't like how the Torx bit fit in there, and I did happen to have the triple square, and the triple square fits so much tighter in there because you do not want to risk stripping that out, because then you spend hours on a bolt, you know.
And the one tool out of your tool set that you hardly ever use working on one of these Porsches is a 16 millimeter, and that's what these bell housing bolts are. So, so if you don't have a 16 in your tool set, you're going to need it for this.
Okay, so we removed we had this on 2 blocks, but we removed the first block and it already started to separate from the motor here. We also made sure to use the block that we removed to support the engine, because now it's going to need to sit on its own without the help of the transmission.
Yes.
All right, so let's go.
You got it? You got most of it, because I don't have much of a grip.
All right, that wasn't so bad.
No. Clutch doesn't look too bad, you know. Flywheel's dead.
What do you mean?
It's got a little bit of bounce back. It's a good thing we brought you a new one, though. See how it doesn't want to, it wants to kind of stay?
Yeah.
It's got a little bounce back. There's actually a spec for that because it's a dual mass, so. Bust off the pressure plate bolts and then bust off the flywheel bolts.
Well,
Clutch disc. Don't even look bad.
it's not bad, right?
No.
I'm a great driver, that's why.
Keep that as a spare.
Yeah.
In your glove box.
Been a little hot.
Huh?
Slipped a little bit.
Yeah, it did.
Autocross does
Autocrossing,
that. Yeah.
Yeah.
Zip them off? Any particular
I
pattern?
just take them off. Maybe break them all loose. And go across. Always go across. Go like over there. All right, so now we got the transmission separated. The next thing is to remove the clutch and pressure plate. That's what Vu has in his hands. So these were installed back when he did the original IMS retrofit using the ceramic hybrid retrofit bearing several years ago. Do you remember when that was, Vu?
Oh gosh, it was probably 2009.
Okay.
It's been a while.
Yeah, so it's well beyond service interval, both in time and how many miles did you have on it at that time?
I probably had about 65,000 miles. And it's
Okay,
90.
so 30-some
Yeah.
thousand. So it was within the mileage
Yep.
interval,
sure.
but the time is just as important as mileage, and a lot of people don't realize that. But going all the way back to the very beginning with the IMS retrofit bearings, everything's had a service interval. So we're beyond that, so that's why he's going to install the IMS Solution, which is, of course, our permanent fix for this, because it doesn't have a typical ball bearing to wear anymore. We're actually going to use the engine's oil to support the radial and longitudinal loads of the intermediate shaft.
Yep. So I'm going to go ahead. I've already loosened these. I'm going to take these out. You guys go to the other side because I think you're going to start to set up top dead center.
Yep, got my 24 millimeter wrench. We're going to go over here and get ready to put us on TDC. So if you notice, there's a series of holes around this crankshaft pulley, and one of them is shaped like a teardrop, which is this one here. This signifies where we would be at top dead center on the number 1 and number 4 cylinders. Of course, when TDC 1 is actually on true TDC, TDC 4 is on TDC overlap. So at that position, we can carry out our IMS retrofit project with the IMS Solution, and we're going to lock the crankshaft here, and then we're also going to lock one of the camshafts to hold it in place during that procedure. So this is a tool that comes in the IMS Retrofit IMS Solution Supplemental Tool Kit, and it's made to lock that crankshaft position with a portion of the engine case that has a raised boss. So you notice that I'm turning the engine clockwise. I always want to go clockwise, which is the direction of rotation. And then I'm going to start paying close attention, because when the little notch right here lines up with this arrow on the crankcase, that is where my teardrop is aligned with the boss on the crankcase that will lock it in place, okay? So I kind of sneak up on it, I get pretty close, and then I'm going to push in on this while I turn the engine just a little bit, and then it will go in. There, it's in all the way. So you noticed I just went up as quickly as I could, rotate the engine just enough so this will go into place. I do not want to counter-rotate the engine counterclockwise if I miss that, because it's going to put some undue slack in the timing chains. That could be a critical thing for us. So if you miss this as you're turning the engine around, then you're going to have to turn it another 360 or 720 degrees if you want to get it back to the same location, and then put the pin in. You just can't turn it counterclockwise. Yeah, be ready. Weighs 37 pounds.
Oh, it does.
Yeah.
Oh, yeah.
Told you. And it's important that we pull these tensioners out to remove all the spring tension, all the load from the timing chains. So when we go to extract the IMS bearing that's currently in the engine, we will not have a misalignment of the intermediate shaft in the crankcase housing.
And then this one, what size is this one?
32. They're all 32s. This goes in here, but now you're seeing part of the problem is that since your cam deviations are out so far, this is not going to properly lock. See how it's not going in there all the way? Now the reason for that is because, if you remember, going back to Vu's IMS retrofit pre-qualification procedure, he found out that he had high camshaft deviation values. And that deviation value is now being physically displayed here because the camshaft is not in the proper position. It's not that the crankshaft's in the wrong position. It's not that anything else was done improperly. It's basically that the chain ramps and the guides that hold the timing chains in place for these camshafts are out just a little bit. And that was about 10 degrees, I think, Vu. That 10 degrees is enough to illustrate this physical misalignment that we have here now. So we just need to rotate that around using the tool just a little bit, because there is some play in those cams. But this is the problem. If you were doing this job and you weren't going to do the rest of this, that tells you how far out that is. You see what I mean? And that's a pretty good ways. This further explains the reason why Vu is going to have to go through and do all of his timing chain guides and those 4th and 5th timing chains to correct this camshaft deviation. It won't fix itself. We have to go inside the valve covers, we have to replace some parts, we have to get the camshaft timing back where it belongs, and then this tool will be properly aligned in this exhaust cam. Okay, so at this time we are at the position where we are ready to remove the IMS retrofit bearing. So we're going to remove the spiral lock that retains that, and then we're going to use the special bearing puller that I came up with many moons ago to extract the bearing. So that's the same process we would do if you had an original bearing in this engine. The fact that it already has the LN Engineering IMS retrofit dual row bearing in the engine only changes things a little bit because we have an external spiral lock that we'll be able to remove using a small little hand tool and get it out of the equation, where if you had the original dual row bearing in the engine still, we would have to use the same special puller, but a lot more pressure on that puller to remove the factory dual row bearing, because it has an internal wire lock that must be broken during the extraction process. So now further, you see we have removed the flange, and we also have removed the bank 1 timing chain tensioner and the timing chain tensioner for the intermediate shaft, and we did both of those prior to removing this flange. It is absolutely essential that that is carried out in that manner, because if you don't do that, you're going to end up with a misalignment of the intermediate shaft inside the housing, and it's going to put it in a position where you cannot extract the bearing easily using the special tool. What you see here is what you should see when this work is being done, either professionally or as a DIY. when you do this with a dual row that has not been pulled before, it is scary. Like you're putting torque on that thing and then all of a sudden it goes kapow. I've broken one stud. Long story about that one. Yep, 2 wrenches. You're going to counter hold the stud part, and then you're going to turn the nut. Yeah. Okay, now counter hold that. Yep. And you'll want to use the open end on that wrench, otherwise you're going to be chasing back and forth. There you go, just like that.
I want to turn this one?
Yep, you're counter holding with your left hand and you're tightening with your right hand. And just keep going. Yep, keep going. Yep, keep on cranking. See, if this was the original bearing, it would have already went like, you'd have tightened it to the point where you couldn't tighten it anymore, and it would have went kapow. Now, what's significant about this puller is that it puts all the load transmission from the pulling directly on the back of the IMS. Before, we used to do it on the back of the crankcase. So what would be the problem with that?
Pulling on the back of the crankcase?
Yeah.
Do you deform the crankcase?
Well, you could bust a hole through it, right. But it also is trying to separate the IMS shaft because it's not supporting on the back of the shaft. Right. See, my design, pull the sprocket off the shaft, you could. The bearing out of the shaft. Exactly. And that's a failure anyway. Call it motor failure 24 out of 31. So literally, that you could create an engine failure. That's what drove me to make this tool. There it is. There you go. You're gonna have some oil come out. Oh, nice. Now, we're going to have to put in the video that if you do that with a regular bearing, then that means your bearing's failing because they're sealed bearings. This is not a sealed bearing, so it's okay that it did that. Okay.
So when we're pulling this part.
Yes, that stud is the other side of the stud. So if you had an original bearing and that bearing was failing, you would have metal debris scattered all around here. And at that point, that metal is already getting in the oil and it's already causing other collateral damage in the engine that you don't know about. Right. So the fact there's no metal there, yeah, I mean, obviously it's a retrofit bearing. It's failure resistant anyway, even so many years after its service life should have ended. So now we can unthread that nut, take the stud back off the bearing, and we can inspect the bearing on the bench.
So believe it or not, Jake, I have never seen the IMS Solution that actually went into my motor because obviously I didn't install it initially. And being the hoarder that I am, I actually have my original bearing. And I understand today when you do it, this has to be sent in and registered, but I did this so long ago, I don't think that particular procedure existed. So this is my original dual row bearing. And then this is what we just use the tools, and we'll go over the tool in a second, of the LN bearing with the ceramic balls, and we'll talk more about the details of that. But I noticed immediately that there is a difference in width, and that has to do with how not dramatic it was for me to pull this one out. But before we get into that, what's the difference between my original OEM bearing here and the LN bearing that I put in?
Okay, so first off, Vu, I have to tell you that if today you were to carry out this procedure and you put this bearing into your engine, there will be an extensive process and procedure for you to indicate on your vehicle that it has been retrofitted. It has a serial number, and then we have an IMS registry where you're able to log that this work was done, because new buyers of vehicles want to make sure this work was done. They want to know when it was done and if it was properly qualified for the procedure, which you've already done. So part of that would be sending your original bearing in so we can make sure that it was not in process of failing at the time this was done.
Gotcha.
So the reason for that, and so everybody understands it at home, is this is not a repair product. when we invented all this stuff and came up with all of this, this was a service product. It was never intended, and still is not today, to repair a failing bearing. So the reason for that is because once one of these bearings start to fail, you have wear debris. And where does that wear debris go?
Goes all into the oil, and then it gets distributed all over the inside of the engine.
That's right. You can actually create liquid sandpaper with your oil if these really small metal fragments that are microscopic in size suspend in the oil and get distributed all through the engine. And people say, well, that's what the oil filter's for. And I won't argue with that, but I will say that it does not filter 100% of the oil 100% of the time, okay? And because of that, and the fact that you have splash oiling of a lot of components, cylinders and pistons get a lot of splash oil. They also have oil piston squirters that deliver some pressure-fed oil to them, but you have splash-fed oil that is not filtered. So that could lead to other problems, collateral damages. So we want to make sure that as part of the pre-qualification, the person doing the work makes sure that you do not have any failures going on with your cam deviations or any of that, and we want to make sure that you don't have a bearing failing that is going to end up taking out the rest of the engine, because people do this to enhance their investment. So the idea is we want to protect that investment and make sure they don't spend money on something and then have that create a problem down the road.
Right, because someone who is unscrupulous could have had something fail, put something like this in, and shows that it has the new bearing put in, but the damage was already caused.
Well, this happens all the time. So we even see people take these original bearings and sell them on eBay, okay?
No way.
Absolutely.
Huh.
There's probably one on eBay right now. So the thing I want to also say is, once we go over the tools and how we extract this, we're pulling from the inner race of this bearing. So all bearings have an outer race and an inner race, okay? And with this particular bearing, the inner race is parked and the outer race turns, okay? That's called an outer race rotation bearing. Inner race rotation bearing is like this, okay? So if you ever pull one of these bearings, if it's an original one, if it's ours, any of these retrofit bearings, you must throw it away. Because when you pull from this center stud, you're creating microscopic dings from those balls into the race.
Right.
And then as it operates, those dings turn into wear spots, and then the balls start to stop, and they start to stagnate, and then they start to skip, and then you have wear increase. So you can't remove one of these and ever put it back into service. Okay. So if you try to buy one of these on eBay and you put it in your engine, you're asking for a problem.
Don't do it.
No.
Now, the other thing that a lot of people have asked me when I told them that I was about to go down this road with the IMS solution, and they, well, do you still have your original bearing in it? And the answer, of course, is no. I did it back in 08, 09, and I moved to this one. But I understood when I had this one put in that it was also not a lifetime solution. There is a time limit, there is a mileage limit. So I already started to save, so to speak, knowing that I was going to have to do either a replacement one of these as maintenance and or do the full-on solution, which came out, I think, I didn't know about it when this was replaced, but now that it is, that I'm moving to the other solution. And we pull this out, and thankfully, feels like it's in perfect shape. And people say, well, that seems like you probably didn't
wasted money.
Wasted money.
Yeah.
Actually, I look at it as I'm glad it is in perfect shape, meaning nothing's wrong with my case or anything, fragments in the oil, and when I put the next solution in, that the engine is in good health.
Well, all too often, people look at this and they say, well, they want it to come out with a problem. Like they want to see that they're spending money for an actual reason. So it kind of blows me away that they want to see debris, or they want confirmation that they are spending money wisely, when at the end of the day, you should be jumping for joy.
Right.
Especially if you pull an original bearing
and
there was no metal anywhere on it and it still feels nice and tight and that bearing's okay, okay? But you should be jumping for joy that this is preventative, because remember, these are not service, or they're not repair items. They are service items. So we are servicing it. Now, a lot of people say, well, like you even said, why didn't you just put the solution in? So it's very confusing, because today, everything's an IMS solution, okay? But it's not. This bearing is an IMS retrofit bearing, okay? So there are different generations of this. And people generally don't understand what retrofit means. It means we're going to change it. We're going to retrofit a bearing into it that it didn't have. Meaning we're taking this ceramic hybrid bearing, which is also a dual row, made of more superior materials than the factory, which is a conventional bearing. This has silicon nitride ceramic balls. That has a standard steel ball. And what makes this a ceramic hybrid is that it is a hybrid. It is steel and it is ceramic. And silicon nitride is super wear resistant, super friction. Friction reduction is huge inside these bearings. And where you don't have friction, you also don't have heat or wear. So that's a key. But since everything is a solution today, there's still only one IMS solution, and that's the one that I invented many years ago. So when you did this in 2009, we believe is when you did it, and we know it was a long time ago because it was pre-date codes on the parts, okay? Then at that point, the IMS solution was fully invented, and it was perfected, but it was not fully developed as a kit.
Right.
Because originally, I came up with the IMS solution, which is the plain bearing we're going to talk about, triple patented, because I wanted to put it in my engines. So honestly, Charles had to convince me to start getting this into circulation, because originally it was like, if you want this, it's going to come in an engine, and the beginning of them, the first ones, did come in Flat 6 Innovations engines. So that was kind of the idea, and then over time, it's like, okay, it is a true permanent fix because it doesn't have these pieces in it.
Right.
And we'll go over in a minute how many pieces it gets rid of in this equation. But that's why it is the solution, and that's why this is a retrofit. Now, every action associated with pulling these out, these are all IMS retrofit products, right? It supports doing the bearing. But that's the difference between a retrofit and a solution. Basically, the solution is a plain bearing.
Well, let's talk about the tools. So I pulled this one out, and it was quite drama-free, and that has to do with this spring clip
Okay,
here.
so that's called a spiral lock.
Spiral lock,
So the
okay.
reason why this one is more narrow than this one, when the factory made these original dual row bearings, they had this bearing specially made to be fit into the intermediate shaft during the pre-assembly process. And then they would take a pre-assembled IMS shaft that had the flange and the bearing all assembled into it. They would put it into a new engine. So the reason this one is more narrow is because it had an internal wire lock. So this internal wire lock is actually inside the intermediate shaft.
So there was a wire lock here, and so had I been pulling with a tool an original bearing, you almost have to pull it until the wire lock just snaps.
You are going to use mechanical advantage with my tool that is made exceptionally heavy duty for this purpose, and you are going to overcome that clip.
Okay.
And it is going to break it,
Just
or it will
destroy the
shear it.
clip. Yeah.
Exactly. It does not harm the shaft.
Right.
Now, I will say sometimes it will leave enough of this behind inside the shaft. You need to take a pick, go around inside that groove and make sure it's all out,
Right.
because you're going to put this back in its place.
Right.
Okay? So we made these bearings more narrow, so this which is about a 1/16 of an inch thick
Yeah.
on this corner here, to take up that gap. So what you see is we have to have the space to install this inside the original groove in the shaft. That is what retains it. Now, there are some other fixes out there that do not use anything to hold this in.
Oh.
They're just depending upon the bearing sliding into the shaft to hold it in place. Now, I will tell you while he's zoomed in here that the problem with that is you can see that your original bearing, if we spin it around here a little bit, was running a little loose in the shaft. This is called fretting, okay? Fretting is when you have a part that is running a little loose inside of a housing bore. It will create a little bit of mechanical wear because it's moving. You can also see the same thing happened here, okay? Because the dual row shafts have a varying degree of internal diameter on the inside of that shaft. So we have to make that so it would fit all of them universally, which is what the factory did as well. Okay, so the issue with this is if you did not have this wire lock holding this in place, that could just stay parked inside the shaft. And I've seen that happen with some other technologies that have been employed over the last 15 years.
And with this ring here, I was able to pry right there and pull this off. So now this just came out nice and smooth with this. So let's just show everyone. I know we have some video footage of it, me doing the job, but basically this was on the motor, and then I put that on, and then I connected this to here. And what happens is as you drive this nut down onto the shaft here, it would just pull, 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 nice and straight, nice and even.
And it also supports the back of the shaft. So that's something that I want to go over is the way that this tool works and why it's a safe way to do this. Because it's not the other way that we did this in the very early days before I invented this tool, it was not safe.
Yeah.
But we didn't know what we didn't know at that time.
So back in the day, did you just put something on there and just do like a slide hammer to pop them out?
Well, we tried that, but you can't get enough mechanical advantage to break the clip.
That. Okay,
okay?
Gotcha.
It would just bounce. Okay,
Right.
You'd have to have a 50-pound piece slide to do that. But the problem with that is it would actually try to separate the intermediate shaft. And that's motor failure 24, where the intermediate shaft, which is a 4-piece assembly that's all swedged together from the factory, would actually separate. So over the years, as we started doing this, you know, I think it's also important to say this procedure is something that we had to invent from scratch. And Charles and I worked very diligently on this, and I used a lot of practical application from working on everything in my life, from tractors to Porsches, to do this. So in the very beginning, we tried slide hammers, didn't work. We also had a way that this tool, a portion of this tool would use another, like a 2 or a 3-arm puller. It would go against the back of the crankcase and it would put pressure there to pull the bearing out. The problem with that is it tries to separate the shaft. Even though I never had one separate, you don't want to give it any help because we know those shafts can fail in that manner too.
Right.
And that's not an IMS bearing failure, that's an IMS failure where the shaft fails. So when I invented this tool, I basically took what we had been doing and I said, I want to make it where I'm exerting all of the pulling force, all that mechanical advantage, which is a lot when you're trying to break this snap ring on the original dual row. I wanted to put all that load on the back of the intermediate shaft only. Because at that point, I was not trying to pull the shaft apart, I was keeping the shaft together because I was pulling the bearing out of the shaft's bore where this was setting directly parallel to it, okay? So that is the biggest advantage of this tool. And now these tools have been used all over the world tens of thousands of times to do this, and I do not know of a single case where any of these have resulted in a shaft failure because it really can't happen.
To pull this one out here, this is all I used here. What's all this?
Okay, so the kit, and there's different ones of these. So over the years, you know, the original studs have a certain diameter, they're metric, blah, blah, blah. A lot of our kits are larger, stronger studs, and then we've had to make different adapters that allow you to pull these bearings out, okay? Because just like what you're doing, you have people who want to put a solution in it or just put another retrofit bearing in it because theirs is timed out, either mileage or time. The service interval is there. So that's why this kit includes all these different adapters so you can pull original bearings, you can pull aftermarket bearings, you can do all that. You can even pull out an IMS Solution if you ever needed to because we see people who have a certain engine in their car, it already has an IMS Solution, and they end up wanting to try to pull that solution out and put it into another engine.
Put it in the next engine.
But that is something where you can damage the bushing. Here we're saying don't do that because you're damaging the bearing. There, while you could do that, you're also going to end up possibly damaging that bushing, and it could change the dimensions of it. So if somebody ever wants to do that, I highly recommend they call LN for some directives. It can be done, but it needs to be inspected afterward to make sure it did not get damaged.
Damaged during removal. Okay. So what is this barrel here? Is this for different size?
So these are driving tools. This is actually the driving tool we're going to be using to install the IMS Solution bushing. So what you see here are these bearings. The bushing is just one aluminum piece. People look at it, that's just a piece of aluminum. No, that aluminum is highly researched. It is a material that is hard to come by, and they sell it by the inch. It is extremely expensive. Where this is just a chunk of 6061 because it's a tool, that's not what the other stuff is. It's a special material that is able to carry a load. It has a different silicon content. It is fairly self-lubricating, all those sorts of things to fight startup wear. So here, this is made to drive that original, or the solution bushing in. So it goes inside, supports inside of it, then you hit it on this end and you drive it home mechanically.
Okay. Got it.
That's what that tool does. This tool works a lot the same way, but it's made for putting these bearings in.
Ah, okay.
Okay,
Gotcha.
so that
Yep.
would be for your dual row and your classic single row bearing. Then with today, we have another offering, which is what we call the Single Row Pro. And that is a dual row bearing that fits in the space of a single row. So it doubles the load carrying capability.
Okay.
That uses a special tool that I invented called a Faultless tool. And that particular tool is made to deliver that special width bearing that also uses an internal wire lock like this. But it compresses the wire lock as it goes into the shaft, almost like a piston ring compressor.
Right, and then once it gets to the groove, it pops
Out, exactly. So that's what all these are Faultless tools. That's the brand we created for this, but that is the Faultless tool. And that tool can take the place of this as an extractor, or it also can install a bearing. So it does both of them by changing a coupler that's inside of it. So it is a true dual roll component or tool. Now, that's something that usually shops have. You know, all the certified installers, we mandate they have that tool, and you can use it to install any of these. You can also use it to install a solution if you want.
What's this?
This is something you don't want to have to use.
Okay.
Okay, so when we were talking, you asked me what happens if this stud that we're pulling out here breaks.
Yeah.
In that case, you take the stud, you knock it out with a hammer, it goes inside the intermediate shaft where you can go collect it later.
Yeah.
Then you finagle this thing inside the bearing race, okay? You stick it through,
yeah.
and it sticks in behind it, okay? And then it allows you to take this threaded adapter, thread it into here, and pull it.
I see.
So that way, the fact that you broke the stud is irrelevant at that point.
Then you'll be using this to pull it out.
And you're still pulling from the same location.
Right.
It's just that you've broken the threads off. So this tool is something you never have to use, or hope you never use. Now, I've used it twice in all these years, just 2 times.
Yeah.
But you know, I kind of know when to stop when things are starting to go south when pulling these dual row bearings. And people call LN all the time, or they even call Flat 6, and they say, "Hey, I'm doing this job, and I've really got a lot of pressure on this thing. I'm afraid something's going to break. It's creaking, it's popping. You know, I can't put any more force on it." And I say, "Go to lunch." And they say, "What?" I'm like, "Walk away from it for 30 minutes to an hour."
Yeah.
And I said, "You might hear a big bang." And sometimes it will release just by itself if you leave it loaded up.
Yeah.
Other times, we've had people, you know, have to really crank on them with big wrenches, and at that point, you can break the stud. But you very rarely have the need for this.
Okay.
But at least we try to cover every base.
Right.
You know, that's the difference when you invent something and you develop it and you use it and you have a life built around it. At that point, you know what people are going to encounter. There's no question mark.
Right. What's this for?
This installs the spin-on oil filter adapter for the IMS Solution.
Okay.
So you'll see that when we get to that point of the install. This is a cam timing tool for the 3-chain engines. It also can hold the cams as well. A little bit different than the 5-chain holding tool.
And people, they can rent this or buy this?
So either way, so if you buy your bearing kit directly from LN Engineering, then you have the option to rent these tools.
Okay.
If you buy it from a distributor or any other, you know, aftermarket source or eBay or Amazon or wherever you might buy it, then if you didn't buy it direct, you don't have the ability to rent these. If you didn't rent it and you want to buy it, then they're available pretty much everywhere. Pelican Parts, you know, FCP, all the major retailers have it. It's on Amazon, it's on eBay, and sometimes you can buy a used kit. People, you know, do that sometimes. But if you do that, make sure that the threads are in good condition and stuff, because these tools, if you don't lubricate them properly, then it'll strip the threads. You know, things like that. It's all the risk that happens when you buy something used on eBay.
Right.
But don't buy a used IMS bearing.
Right. Yeah. So is there a difference between the effort for a double row bearing in extracting versus a single row?
Yes.
Okay.
So the single row, the classic single row, if you were pulling an original single row bearing, the experience you would have would rival exactly what happened pulling this IMS retrofit bearing out today.
Oh, so much smoother.
Because it uses a regular snap ring pliers. Okay. So that regular snap ring is easy to remove. You know, you go in, snap ring pliers, you pull it out.
Oh, the factory one has a snap ring.
The single row, the factory single row.
Okay.
Yes. You'll go in with snap
So
ring pliers.
that's why it's narrow? Is that why they're more narrow? than this
Exactly.
one?
But you see, they can get away with that because it was a single row bearing. It was more narrow.
Gotcha. Huh.
So, and a lot of people look at it and they get confused. And, if they go back and watch our original, like from 2017, all of our IMS stuff with you guys here at PCA, when you travel to see me at my facility, we went over this. But it's almost like they think the bearings got better over time. And that did happen in mid-2005. But before that, there was a period where things retrospectively went backwards, right? Because remember, we started in 97 with a dual row bearing that went through mid-year 2000. Then they went to a single row, which literally has half the load carrying capacity.
Yeah, single row is small.
Yes, it has half as many parts inside of it to carry the load. Now, and so there is a little bit of an elephant in the room, right? Because people say that these bearings are resistant to failure, okay? Now, for many years, I agreed with this. And it's not because we wanted to sell product that I changed my mind, but it's basically because time and service, okay? And people not changing oil frequently enough, and no, your annual oil service interval is not frequently enough, the oil will start to degrade and it loses its ability to lubricate and cool the bearing. So the problem is that now today, the elephant in the room is that these dual row bearings don't need to be changed, okay? Yours is in good shape, but it's been out of service since 2009.
Right.
Okay?
Right.
Now, at the end of the day, the problem when one of these bearings fail versus a single row, it has twice as many parts inside of it.
Right.
Why would that be a problem?
Just more debris.
That's right.
Yeah.
It has double the amount of debris generation. So the issue is, Vu, that bearing takes too long to finally fail. Does that make sense?
I see what you're saying.
Okay, a single row, a lot of times when people would call me, my record was seven IMS bearing failure calls in a week. I had a logbook of this. That was a record. We haven't seen that in many years because most cars are retrofitted, right? But at the peak, which was before the class action lawsuit and all that, 7 in 1 week was my record.
Wow.
So a guy with a single row car would call me up and I would take the words out of his mouth. I was going down an exit ramp and I'm like, sir, please allow me to take the words out of your mouth. And he's like, okay, there's no way this guy can do this. And I would say, you pulled up to the stop sign and you stopped and the engine stalled. And you're like, well, that was kind of odd. And you didn't hear anything. But then you try to crank it up and you hear what sounds like marbles in a tin can. And the phone is deathly silent. Deathly silent. And the guy's like, how did you know that?
Right.
Well, you know how many times I've had this conversation, right? Because when a bearing failed, we got the phone call. It was going to happen. So we've literally had people Google this failure or this symptom while they were on the side of the road waiting for a tow truck.
Yeah.
And I would tell them what happened. And I'm like, look under the car. Is there a lot of oil pouring out of it? Yeah. Is it near the bell housing area? Well, I don't know where that is, but it's kind of toward the middle. Okay.
Yeah.
Well, the center stud broke off because a bearing failed.
Right.
So at the end of the day, the issue with this bearing taking too long to fail, where the single row just gets it over with. The single row has half as many wear parts in it, and when it breaks, that's the guy sitting at that stop sign, and it's done. The worst thing he can do, and you guys at home, if you have a bearing failure, is try to restart the car.
Right.
You don't know that, but at that point, you're going to bend valves, and you're going to create a lot of collateral damage that you probably were able to skate by when it finally stalled, because it happened at such low speed. But when you try to turn the engine over, things are going to go south quick.
You're spreading everything everywhere.
So the reason with the dual row bearing, in the position that I have, and I've had with this for many years, when people say, I don't need to change it, the reason I say you do is because that bearing takes so long to fail that it will generate a tremendous amount of debris that you don't know about for many, many months sometimes. And it goes through the whole engine. So then you end up with scored bores that are insanely scored. All your bearings are taken out because the filter can't handle enough of it. So I've seen engines that were driven with a failing IMS bearing, and the bearing never completely failed. But that engine came to me for a reconstruction, and metal had got through it so bad I had to throw the cylinder heads away. You know why that is? Because the cylinder heads have no camshaft bearings. So when all that oil makes its way all the way out to those extremities, and it scores the heads and the cams, you have to throw them away. There's no bearings to fix it, okay? Where a lot of engines have a cam bearing in the head and you would just change that bearing. These engines don't have that. The cam rides in the head. So that is how much debris that bearing is capable of generating before it gives up. So the bearing is too strong in some ways. It will wear, but it takes too long to completely fail, and it allows the debris generation to be so high that the collateral damage is greater. And that is my position on the dual row bearing.
Wow. So that's why I proactively change this one out, and that's why I'm proactively changing this one out as well.
Yeah.
And I'm going to a part, I think now would be a great time to bring in what we're putting in, because you'll notice the vast drop in number of parts that the new bearing will be.
Absolutely.